What's rarer than supernova? Rarer than formation of ring galaxies? Or even rarer than planet collisions? There are some moments in space which happen so rarely that we don't even know if they happen at all, and we will look precisely at those ones. The universe is a violent place where even a star's life can be cut short. This happens when a star finds itself in a bad neighborhood, specifically in the proximity of a supermassive black hole. As a star wanders nearer to the black hole, it is subjected to an escalating gravitational drag from the supermassive black hole, which eventually overpowers the forces that maintain the star's integrity. This results in the star being disrupted or destroyed, also called Tidal Disruption event. After the star has been ripped apart, its gas forms a accretion disk around the black hole, which can be observed in nearly every wavelength. You surely heard about wormholes, a tunnel that connects two distant locations like galaxies by simply bending or warping the space-time. However, if a traversable wormhole were to exist, it would require exotic matter with negative energy density to keep the tunnel stable. As wormholes could pop here and there and disintegrate in seconds, it's almost impossible to spot them and keep stable enough to pass through them, belonging to a very rare occurrence indeed. Here we have a pulsar. Pulsars are neutron stars, dense celestial bodies with the mass of Sun compressed to a city-sized sphere. But these neutron stars rotate rapidly, up to 700 times per second, while also creating a powerful magnetic field. They are called pulsars as a result of emitting radio waves in beams misaligned with their rotation axis. It is believed that to reach the rotational speeds so high, pulsars consume a companion binary star. The specific conditions for their rotation make them a rarity in cosmic terms. In space, there are a lot of massive explosions like supernovae, but what happens when two neutron stars, or a neutron star, and a stellar mass black hole collide? A phenomenon called kilonova happens. When these collisions occur, a vast amount of material is ejected from the neutron stars. Thus, these events produce the most powerful electromagnetic explosions in the universe and are responsible for showering the universe in gold and platinum. Before we move to next event, don't forget to subscribe. Next, we have some space art on the list called Quazar microlensing. It is a phenomenon observed in distant quasars, which are extremely bright and energetic centers or cores of distant galaxies. When a foreground object, such as a star or another compact mass, passes in front of the quasar, its gravitational field acts as a lens, bending and focusing the quasar's light. This gravitational microlensing effect leads to a temporary increase in the quasar's brightness, creating distinct variations in its observed light curve. Which looks quite interesting, don't you think? Moving on the most powerful, violent, and rarest explosions in the known universe, gamma-ray bursts. The cause depends on their duration. Shorter bursts result from neutron star mergers, while longer ones, lasting hours, occur during massive star collapse to form a black hole. Remarkably, a gamma-ray burst can release as much energy in seconds as the Sun does in its 9 billion-year lifetime. Luckily, the likelihood of such an event is low, ranging from once every 10,000 to 1 million years. Now envision a magnet of such strength that it could erase all credit cards on Earth from a point halfway to the Moon. A unique subtype of neutron star called Magnetar could do it easily. Obviously, it has an exceptionally powerful magnetic field. This magnetic field is approximately 1,000 times more potent than that of a typical neutron star, and around 1 trillion times stronger than Earth's. So, Magnetars stand out as the most magnetic stars in the cosmos. Disturbing fact is that if you approached Magnetar within approximately 600 miles, it would be fatal to you, as its magnetic force would swiftly strip the electrons away from atoms, destroying any human body. Another rare event on our list is hypervelocity star ejection. It refers to a phenomenon where stars are expelled from a galaxy at exceptionally high velocities. The process typically involves a binary star system, where one star gets too close to the supermassive black hole. The intense gravitational forces from the black hole can disrupt the binary system, shooting one of the stars away at tremendous speeds, while the other remains in orbit around the black hole. One such event already happened in the Milky Way, known as Hypervelocity Star 1, which had been expelled from galaxy at speed of 2.3 million miles per hour. Now we have here a binary system of a star and white dwarf. White dwarf is a dense leftover from a star that has exhausted its nuclear fuel reserves at the core. What makes this combination unique is that sometimes the white dwarf gathers material gravitationally from a nearby stellar companion. Once the white dwarf amasses mass to around 1.4 times that of our Sun, it breaches a critical threshold, rendering it incapable of sustaining its own gravitational force, ultimately resulting in an explosion. This one has a special name, Type 1a supernova explosion. When two black holes, massive objects with intense gravitational fields that prevent the escape of light, go through a merge, a substantial release of energy occurs, manifesting as powerful jets. Although this is pretty challenging, as it could only happen in the binary system, and only if the orbit of the binary black hole around the central supermassive black hole is exactly right. The merging process, driven by the circular dance of these colossal entities, disrupts the fabric of space-time itself, generating gravitational waves that ripple outward through the cosmos. If you want to know more wonders about light speed travel, watch this video.